Hello, good evening, students. Welcome you back for another important session on transition elements. What I've been talking with you, students, the properties of the transition elements. We have been discussing some of the important properties of the transition elements. We discussed that transition elements show magnetic properties. Did we discuss that, students, with you?
Yes,
Magnetic
sir.
properties of the transition elements.
Yes, sir.
But it depends on why they show paramagnetism, why they show
Sir, due to
paramagnetism,
the
and
unpaired
how can we calculate
unpaired
the magnetic
electrons.
moment. Students, we have shown the paramagnetic behavior of the transition element metal ions because they have unpaired electrons, and the formula we have also given you how to calculate the spin only magnetic moment. The mu is equal to
Yes,
square
sir.
root of n into n plus 2. N is the
Under
number of
root n
unpaired
plus
electrons. Now we
plus
get the value in Bohr
unpaired
magnetron,
electrons.
students. Then we have shown you
Yes, sir.
why they form colored ion, students, because of the, what is the reason for the color of the metal ions of the transition, students? Two important
Sir,
properties
they
we have
form
discussed,
colored
student,
ions
already.
because
Magnetic properties, which was due to unpaired electrons and color of the transition element, they form colored ion, student. Color of the ions, what is the reason?
absorption of light in the visible
What we
region due
said,
to
DD transition.
excitation. DD transition, excitation of electron.
So there is a electron excitation takes place in the visible region. When electrons absorb light in the visible region, they undergo excitation of electrons from D to D, T to G to EG, T to G to EG. Student, we have shown you the splitting of the D orbitals take place. Now we are coming to more important properties of the transition element, students. As per our syllabus, you can see that on the board we have formation of the complex compounds, students. First question will be, what are complex compounds? What are complex compounds, students? What do you mean by complex compounds? Or in the next chapter, we are likely to study the coordination compounds. What are these complex compounds, student, or what are these coordination compounds is a complete chapter which we will be studying. Actually, the transition metals have metal ions. You have metal ions, student, metal ions. Mn plus. This is our metal ion. It could be 2 plus, it could be 3 plus, or different oxidation states could be there. Now, in this, you know that in the transition element, students, you have metal ions and they have got 3D. If I consider the 3D series, they have 3D vacant orbitals are available. 3D orbitals are available, students. 3D vacant orbitals available. So they can accept a pair of from whom? Those which are molecules, such molecules which can donate the electron pairs. Molecules, students, or species which can donate electron pairs. What are those species known as? These are nothing but
Metals,
Lewis bases,
electroporation.
and in the complex compounds we call them as ligands, student.
Okay.
Ligand, these ligands have lone pair of electrons to donate. They can have one or more ligands can be present in a species. So you have metal ions, the charge is very high. These transition elements, I am saying transition elements, they have small size and high charge, therefore act as strong, and d orbitals are there and they have 3d orbitals available, so they act as strong Lewis acids. They can accept electron pairs from the ligands, and they can then result in the formation of certain compounds which have characteristic properties and such compounds are called complex species, or what we call as complex formation. Complex formation is an important property, students, which will be formed. For example, if I say that there is a copper ion in the solution, student, and if you add ammonia in this, what happens, student? What happens? This ammonia has got lone pair of electrons, and then what happens? It acts as a ligand. This is my Lewis acid. It acts as a ligand, student, and it can donate its pair of electrons to the vacant orbitals of the copper 2 plus ions. The result of that is, students, it forms CuNH3 4 2 plus complex. Now, when I write something in bracket, student, that means that these NH3 molecules, they are forming coordinate covalent bond with the copper. They are donating pair of electrons to the copper, student. But I am trying to say that you have NH3 students, NH3, NH3. How many you have? 4 here. So they are forming dative bond or coordinate covalent bond with this copper 2 plus ion. This
Okay.
is copper 2 plus ion, student. So you can see copper 2 plus ion, they are giving their lone pair of electrons to the copper. So we write in bracket means this has a characteristic properties. This has a characteristic property, student. Ammonia is forming coordinate bond with the copper ions. It's bonded with the copper. So we have written in a square bracket 2 plus. These are called complexes. Student. Similarly, if I consider, student, AG, AgCl. AgCl, you are aware of this. AgCl is a solid white colored precipitate. Are you aware of that?
Yes, sir.
What is AgCl? It is a solid AgCl, silver chloride white precipitate, you are aware. And if you add sodium cyanide in it, student, if you add sodium cyanide in it, what happens? It forms a complex, student, AgCN2 minus. So this complex is formed. Student, AgCN2. So here you
Okay.
can see that there are two CN which are forming coordinate covalent bond with the silver, and since the charge of the CN is -1, therefore here silver is in +1 oxidation state, student, +1 oxidation state. This is a complex ion, this is soluble. This is blue in color.
Yes,
Tetraamine
sir.
copper, it is used for testing of the copper ions by copper amine test. So
Yes,
this
sir.
is a blue in color, student, and here this is a soluble, this is soluble. So here are some of the examples, student, which we are talking of complex compound formations. Similarly, if I consider ferrous ion, student, ferrous, this forms a complex with the cyanide ion, student, and what you get is a complex or compound FeCN4. So it is 2 plus, it is 4 minus, so the will be charge will be 2 minus. These are some of the complexes, student, which we are talking about. We also have complexes of the iron, FeCN6, 4 minus and 3 minus, which are different oxidation states of the copper. Similarly, we have Pt platinum Cl4, 2 minus. These are all examples of the complexes which are formed by the transition elements. So transition elements form complexes. Why? Because of the high ionic charge, availability of d orbitals, which can result in the formation of bond, student, and the charge is high charge is there, and size is small. They act as strong Lewis acids. They can accept pairs of electrons in their d orbital, which can result in the formation of the bonds. Is it clear, students, what
Yes,
I
sir.
talked about?
Yes, sir.
Complex formation by the d block elements.
D block
3D series
elements.
we have discussed here, and more we are likely to discuss this. in the coordination compounds. Another important property, students, we are coming another important property, and we are going to be discussing a lot of important properties of the transition elements. What are those? I hope you have noted down this.
Yes, sir.
Complexes, complex formation by transition metals. The question was asked on what is the reason they form complexes, students. The size should be small,
They have high
charge should be
charge
high,
and
and
strong Lewis
availability
as
of
well.
the vacant orbitals should be there, then only complexes can be formed. Now we are going to discuss the catalytic properties of the transition elements. You are aware that we use large number of catalysts in chemistry. Are you aware of that, students?
Yes, sir.
What are catalysts, students? What the catalyst does? Increases the rate of the
Increases the
reactions.
rate of the reaction.
So catalyst will increase the rate of the reaction. But why will anything act as a catalyst, student? What are the reasons? What are the reasons that transition elements act as catalyst? That is the first question. You have seen large number of transition element, platinum, palladium, nickel. You have used iron, student. You have used vanadium pentoxide in various reactions. You are heard the names of many catalysts which we will be talking about, student. What is a requirement? Why the transition elements? What we are saying that transition elements, student, transition metal ions can act as good catalysts. What could be the reasons for that, students? How many reasons we can give? What is the important thing about them? Important point is what we are seeing, students, that transition metal ions have vacant d orbitals.
Okay.
They can participate in bonding. They can participate in bonding, students. Second, they can exhibit variable oxidation states. That means they can change their oxidation state, student, variable oxidation states, I'm saying. So there you have seen plus 2, plus 3, plus 4. So many oxidation states are possible, students. And in the powdered form, student, what will happen? They will have a large surface area. The surface area is important because if you take what you are using, rane nickel powder, palladium, all these catalytic hydrogenation, student, you have heard about this. You have been
Yes,
using
sir.
about this uh, variable oxidation state, vacant d orbital, surface areas. So these, and further you have just seen that they can form complex formation. So in large, when you have a surface and complexes can be formed, student, then also it forms a route for the catalyst to increase the speed of the reaction, because the ultimate purpose of the catalyst is to increase the speed of the reaction. After that, the catalyst is coming back and it is not used up in the reaction, that you already know about it. So some of these properties are known for the reasons. For example, student, for example, can you give few examples examples in which the transition metal ions are acting as catalyst. Student, you have heard about, for example, if I say KClO3 decomposition, if you heat it, what is the catalyst here? You are adding MnO2. Student, what happens?
MnO2.
This reaction becomes very fast. So oxygen gas, when we prepared oxygen gas, student, you are using manganese dioxide as a catalyst. Manganese dioxide is a catalyst here, student. MnO2 is a catalyst in the decomposition of potassium chlorate, student. And you are aware of the manufacture of sulfuric acid by
Yes,
the
sir.
contact
Vanadium.
process.
V2O5.
Can you tell
Contact
me
process. Yes, sir.
which catalyst is used in this process, student? Which catalyst is used?
V2O5.
What do we do in the
V2O5.
contact process?
Vanadium.
SO2 plus O2, you are converting into
SO2 plus
SO3.
O2. SO3.
Which is the catalyst which is used here? You have heard about
V2O5.
V2O5. Vanadium pentaoxide is a catalyst which we are using, student, in this case. So there are other cases also. You are aware of hydrogenation reaction, student?
Yes, sir.
Hydrogenation of alkenes. What you are adding? Hydrogen in the presence of platinum,
Finely divided nickel.
palladium or nickel
Palladium. Nickel.
for hydrogenation in the organic chemistry. So these are all transition elements. Then you are using iron, you
Haber's
are
process.
using FeCl3 in Friedel Crafts reaction. In organic chemistry, you are aware of what was that reaction, student? You are aware iron heat. What do you get? This is acting as a catalyst. So what you are getting?
Catalyst.
These reactions you are aware of. FeCl3 also you are aware of. Then further you have heard another type of reaction which is called aromatization. Certain reaction which we did in 11th chemistry, iron and heated, student. What do you get? See, such reactions are there which we have been telling you in different cases. So some of the very important catalysts which are repeatedly asked, also just giving a revision of the different, there are two types of catalyst, student, that also you know: homogeneous,
And heterogeneous.
homogeneous and
Heterogeneous.
heterogeneous catalysis. Homogeneous and heterogeneous catalysis, student. Are you aware of these, students?
Yes, sir.
When the reactants and the catalyst are in the same phase, when the
Same
reactant and
phase.
catalyst are in the different phase.
Yes, sir.
Here reactants, catalyst,
Are in same phase.
same phase, and here reactant catalyst in
Different phase.
different phase. You know, one very important catalyst which is used for the preparation of high density polyethylene. In the polymer chemistry, we are going to study that what we are converting ethene into polyethylene, polymerization, high density polyethylene, HDP, high density polyethylene. In this, we are using a very, very important catalyst, student. The name is so important. It has been asked many times. Ziegler Nata. Ziegler Nata, two scientists who made it. There is a Nobel Prize also given to them. Ziegler Nata catalyst. Do you know what is the Ziegler Nata catalyst, students? Ziegler Nata catalyst. It's a mixture of TiCl4 and triethyl aluminum. TiCl, TiCl4 and triethyl aluminum, students. So TiCl4 and triethyl aluminum. This is called Ziegler-Natta catalyst. It is used for the preparation of high density polyethylene from ethene, polyethylene from ethene. I hope you have noted down some of the important catalysts which are
Yes,
asked
sir.
many times, students, because organic chemistry also we are using many of these catalysts. Few more names are important which we are going to talk about, students, when we use catalysts. Another important catalyst which you may have heard, Lindlar catalyst. This has been asked, what is Lindlar catalyst, student? You know that somewhere we are using palladium and barium sulfate, which barium sulfate acts as a poison, student. In certain reaction we will be studying that palladium, barium sulfate, some sulfur is also present. So we do the reduction, but controlled reduction. This is used for controlled reduction, students. Controlled reduction process. So that we can prepare certain compounds. Otherwise, what happens? Drastic reduction can take place because this acts as a poison. This barium sulfate acts as a poison, students, and you are also using copper also in many cases. For example, HC triple bond CHU copper and heat. Again, aromatization reaction. So we have large variety of these catalysts which are used in the chemistry, and chemistry is full of catalysts, both homogeneous and heterogeneous catalysts. Some of the reasons we have already told you. What could be the reason for the catalytic property, student? Catalysts do at the solid surface involve formation of bond between reactant molecules and atoms, and then the reaction takes place. So the concentration of reactant at the catalyst surface in heterogeneous catalyst, what happens? In heterogeneous catalysis, what happens? At the surface, the adsorption takes place
Yes,
and
sir.
concentration becomes more, and the result is the reaction then takes place. After the products are formed, desorption takes place. So transition elements have got a quite a good surface area. Therefore, catalysis at the solid surface takes place. Some bond formation takes place. and catalyst transition metals have got the variable oxidation states and vacant d orbitals, so they can form, students, the bonds can be formed. First row transition elements utilize 3d and 4s, 3d and 4s electrons are used for bonding.
Okay.
Electrons are available for bonding. So bond formation is possible in the 3d series. So the increasing the concentration of the reactant at the catalyst surface, and also what is the result of this weakening of bonds of the reactant molecules, this, and lowering the energy of activation. This is nothing but lowering the energy of activation for the reaction. So then the
Okay.
transition metals can change their oxidation states, therefore they can also act as a catalyst. They can act as a catalyst. For example, let us see another example. For example of this student, it is found that iron 3 catalyzes reaction between between iodide ions I minus and persulfate ions and S2O8 2 minus. This is called persulfate ions. Persulfate ions. This is your 2I minus, student. It reacts with S2O. This is my S2O8 2 minus. So what happens? I2 plus 2SO4 2 minus 2SO4. Now this is a reaction. This is catalyzed by iron 3. Iron 3 plus. How? 2Fe 3 plus reacts with I minus, and what will it do? It forms 2Fe2 plus and iodine, and then 2Fe2 plus reacts with S2O8 persulfate ions, and you get 2Fe3 plus, and what you are getting, 2SO4 minus. So here you can see that what has happened. Iron can have two oxidation states, plus 2 and plus 3. So because of this, iron is able to catalyze this reaction. 3 plus is going to 2 plus first. So what it is doing, it is undergoing reduction. It is oxidizing I minus. This goes to 0. This is minus 1. So I minus is oxidized to I2. Then this Fe2 plus is oxidized. This is 2 and this goes to plus 3. And here you can see the persulfate ion. This is undergoing oxidation. It is reduced to SO42 minus. So here, because iron can exhibit variable oxidation state. How many? Plus 2 and plus 3.
Plus 3.
Hence is catalyzing the reaction between I minus and S2O persulfate ions, because iron can change its oxidation state. Here iron can change its oxidation state from 2 plus to
2, 3 plus.
3 plus. So because of that, because of this reason, student, because of this reason, what you find, that this reaction is being catalyzed by iron 3
Iron
plus
3
ion,
plus.
iron 3 plus ion. So the catalytic action of the transition metals are due to many reasons which we have given to you. It is clear?
Yes, sir.
All right, student. Next, we are coming to another important type of compound. What are these compounds, students? Formation of interstitial compounds. What are interstitial compounds, student? What are interstitial compounds? You know that when metals have got particles, atoms in them, what is
Yes, sir.
metal? If you say iron is there, copper is there, zinc is there, all these transition elements, when they are forming solids, when they are forming solid crystal lattices, crystal structures or solids, what do you have? There is a packing of these atoms which take place. These atoms are packed usually when in the solid. What will happen, student? There is a packing of atoms of these metal metals. Which one? Transition metals. And when packing takes place, when packing of these atoms takes place, atoms, we say that they are spherical, they are not perfect, having perfect shapes, and they are distorted, spherical in shape. Student, what will be the result of that? That there will be, after packing, what will happen? After packing, students,
Some
there
space
will
will
be
be
some
left,
empty
empty
voids.
spaces, voids.
Empty voids will be there, or they are called interstitial spaces or interstitial voids. Interstitial spaces or voids exist. Voids exist in between these atoms of these metals. You are in the solid state. In the solid state chemistry, there are two types of voids: tetrahedral and octahedral voids. The sizes are also different. So what can happen if there are void, student? Then non-metals, certain non-metals, like, can you name some non-metal, students? Carbon,
Carbon,
hydrogen,
hydrogen,
nitrogen,
nitrogen, oxygen.
oxygen, boron. Certain non-metals, student, what will they do? Certain non-metals, they are trapped, student, inside the crystal, lattices of the metals. Crystal lattices of the metals. So then, because we cannot fix the stoichiometry of these small atoms, or which are going or fitting into the empty spaces, into the empty voids, when the crystal lattices of metals are packed, student, therefore these compounds are usually non
Interstitial compounds.
stoichiometric. These are non stoichiometry. That means they don't have definite stoichiometry. It is not
Okay.
Al2O3, Fe3O4. They don't have that definite formula, which we say that. The stoichiometry is not fixed, students. It can change because it depends on how many small particles are present in the voids, and depending on how many voids are there and which size fits. Because if the void size is very large, then also this atom cannot fit, and if it is very small, then it cannot enter into the void. And in the solid state, you will learn about how many tetrahedral voids are there, how many octahedral voids are there, and what is the radius ratio. All this is a part of the solid state chemistry. In
Okay.
solids chapter, we are going to do that. But here we are only saying that there is an empty space when the packing of the crystal lattices of these metals take place, and in those empty species, students, non-metals like carbon, hydrogen can be trapped in a non-stoichiometric ratio. So they will form the compounds. Such compounds are called student interstitial compounds. These are called interstitial compounds. You see that every can chemistry different type of compounds are formed, even alloys we will be discussing. They will have properties, modified properties.
Yes, sir.
Their properties will be changed, modified, and somewhere we may be needing those properties. That's why we prepare all these things, and we need, because their conductivity or their covalent or ionic nature will not be the same, and so their properties will be different. So examples, for example, TiC, titanium, Mn4n, and they are saying Fe3,
Okay.
H, VH 0.56. So there's no fixed stoichiometry when we write them. There is no fixed stoichiometry. It can change, student, it can change. These are some of the examples. The formulas do not correspond to any normal oxidation state of the metal. The composition of this
Okay.
compound is not fixed, as we are saying. So that is why we are calling these are non-stoichiometric compounds, student, non-stoichiometric compounds. Their composition is not fixed. It can vary. It can vary depending on how many particles are trapped inside. And what are the properties of, once a question was given, what are the properties of interstitial compounds? What are the properties, students? First thing is that these are neither typically ionic nor covalent. They are neither ionic nor covalent. Their properties have been modified, and they have high melting point. Their melting points are higher, student, higher than pure metals. Why? Why their melting point will be higher? Because earlier there was some empty space. Now that has been occupied by other atoms. So packing is becoming more
Okay.
close, because these non-metals have entered into the vacant gaps, vacant spaces or voids which existed in the crystal lattices of these metals. So they are more densely packed. Packing is more dense now, more atom, more close packing, more others are present. So their melting point increases. Melting point increases. If you need something of a higher melting point, then you will consider them. They are very hard. Hardness is also because you have seen that how closely they are packed now, because the non-metals have entered into the empty spaces, have been occupied. And hardness sometimes approach that of a diamond. For example, borides, some borides, they are so hard. Hardness like diamond, students. So properties have been modified, and they have a metallic conductivity. Metallic conductivity is observed because of the presence of free electrons, and chemically they are inert. They do not want to react. There is a packing of them, more dense packing has taken place. You can note down, student, all this
Yes, sir.
information is important. Questions are asked in many ways about the properties of transition elements. Interstitial compounds have been asked in the paper. What are interstitial compounds and what are their properties? You can note down, students.
So these compounds can have properties that of both
You have
metal
noted down?
and those. Yes, sir.
Okay.
Sir, these compounds will have properties that
Your
of
sound is
metals
not
also.
clear to me, students. Sound is not clear.
Sir, is it clear now?
Some problem is there with the voice. Even you are aware of stainless steel, stainless steel. What is in the stainless steel? You have iron. In the iron, you have carbon. You are putting
Yes, sir.
carbon in iron, and carbon is a non-metal, so it can occupy some spaces, interstitial spaces inside the iron. Properties are modified. So what you get? Stainless steel, which does not get rusted, students. Coming to another important property, you are aware of the tendency to form alloys. What are alloys? You have seen, experienced different type of, in chemistry what you learned, mix two things, you get mixtures. And mixture also, we talked of homogeneous mixture, heterogeneous mixture. Then you said some compounds have definite composition. Now we are talking of alloys. So many types of formations are there, and different properties are there which are of great use to us, so we prepare them and we need them. You are getting jewelry, you see in your jewelry what is happening in the jewelry. No, your gold, pure gold is not used in the making the jewelry. Then what we are using, what you are mixing with the gold, what you are mixing with the silver. So the ornaments which you are making, student, jewelry you are making, what are those? You have heard about brass, you
Alloys.
have heard about bronze, students.
Yes, sir.
Statues of brass, bronze. What you are making? Coins. You are making coins. What you are they pure metals?
No.
So here what is happening? We are now coming to the formation of alloys. And alloys will have some properties different from, or modified properties, which are may be of importance to us, students. So here alloy formation is very important in chemistry. Alloy formation. A formation. In the this you are mixing some non-metals which were trapped inside the cavities or the voids of the crystal lattices of the metals. Here what we are doing, we are mixing metals. ठीक है? Mixing,
Okay.
it is a homogeneous. Alloys are homogeneous solid solutions. What you say? They are homogeneous solid solutions. Solid solutions of one metal mixed with one or more metals. One or more metals. So you have one metal, you mix in it another metal. You mix one or two or more than these two metals, and they are forming a homogeneous solid solution. So the atoms of one are randomly distributed among the atoms of the other. You are saying atoms of one metal, atoms of one metal randomly mixed, randomly mixed in atoms of other metals, other metals. So what will be the result of that, student? They will get mixed up, and what you will get? Alloys. Even you form a large number of iron alloys are known. Large number of iron alloys are known. Ferrous alloys. In ferrous alloys, what you have? You have iron, atoms of the iron. They are mixed with, they are alloyed with students, alloyed with chromium. You can mix chromium, vanadium, vanadium. You can mix tungsten, tungsten student. You can mix molybdenum. You can mix manganese in iron. So you can form large number of alloys. They will get mixed up. They will get mixed up, and you can prepare variety of steels and stainless steel. Variety of steels and stainless steels. So you will have more than one metal. They are mixed together, student. You are aware of so many of these. For example, student, for example, can you name some of the alloys, students? Brass is an alloy,
Yes, sir.
bronze.
Bronze.
They are also used for making coins. What do you have in bronze? Copper and tin.
Bronze, copper, and tin.
And what do you have? Copper and zinc.
Zinc.
And all the jewelry I have been talking, gold is mixed with copper in order to make the jewelry, students. So these are all examples of the alloys. Alloys are formed, Ashna. Alloys are formed. Alloys are formed in this. So here one metal gets mixed up with another metal. One metal gets mixed up with another metal. These metals. Now, what is the reason for the formation of the alloys? What is the reason alloys will be formed? Why will we get alloy, students? Why will the atoms of one metal get mixed up with another metal? What could be the main reason, students?
Uh,
Why will they mix with each other? See that the most important point is if they have similar radii, student, then they will be easily getting mixed up. One atom can be easily replace the other atom. So similar radii, almost the sizes are same. If sizes are almost equal, students are quite similar to each other, then alloy formation will take place. Alloy formation will take place. If there is a large difference in their sizes, then alloy formation is not possible. How will you form the alloys? Then one atom is mixed with another atom. If size is similar, easy to mix, and they will get mixed up. And usually these are the properties are modified and improved, student, and you know that they are hard. They are quite hard, student, and have high melting points. High melting points. Therefore, they are of great industrial use. These are of great industrial use and are being used a lot in our everyday life, students. The properties, so many alloys are there which we will be discussing in uh, the lanthanide and actinides. Also, few of these will be discussed, which will be mish metal, etc., and others. And whenever you are making certain bodies of aeroplanes or others, we are using most of the time alloys. So in industries, they find great application. Industries are using, in industries you are using all this what I have talked today. What I have been talking today is mainly the use of catalyst, the formation of complexes, interstitial compound alloy formation. They are of great applications in industries and everyday life. Students, this ends the main properties of the transition elements with us. So we have
Okay.
discussed the important properties of the transition element, oxidation states, color, magnetic properties, alloy formation, interstitial complex. These are the characteristic properties shown by the transition elements which were not shown by some other elements. And that is why these elements are very important and are of great industrial applications to us.
Okay.
Therefore, we are ending up this talk here, and in the next lecture we will start with the for potassium dichromate and potassium permanganate, two important compounds of the transition elements, and we'll see how these are prepared and their properties, what type of properties they show, and structures of certain important ions in the transition elements. After that, the last topic in this will be the F block elements, which are lanthanide and actinide. Students, so we will be getting questions from every topic which we are discussing. Okay, then we will meet you in the next class, and good night, students. Bye bye. This ends the properties of the transition elements.
Okay. Thank you, sir. Thank you, sir.